Welcome back. This is EC253C and it will be lecture 15. So far we have been discussing about Atmega 328, various instructions of Atmega 328 or AVR microcontrollers. Today we will be discussing some more instructions related to AVR input output ports. So first we'll be discussing about the various input output ports of AVR microcontrollers, in particular Atmega 328, and then we'll be discussing about some of the instructions that are associated with these ports, how to get the data inside the microcontroller and how to send the data to the outside world from the Atmega 328 microcontroller. So AVR input output ports, AVR IO ports. Actually, number of input output ports, or therefore number of input output pins, it varies from member to member in the AVR families. Some AVR microcontrollers, they have got only one port or maybe 3 to 4 pins only for input output, and some of them they have got maybe 10, 12 ports. So it depends upon the microcontroller. In our case, in Atmega 328, which is a member of Mega family, and we are discussing in this course, it's actually a 28 pin IC. It comes in many packages, 28 pin IC, maybe in dual inline package. It also has a quad flat package and other package. So it has got 28 pins, and depending on the number of the ports in AVR families, number of the total pins in the ICs also varies. We have AVR microcontrollers which have ICs of 100 pins, and we have AVR microcontrollers which have only 8 pins. And Atmega 328, it has got 28 pins. It's a 28 pin IC. Of these 28 pins, we have 23 input output pins. 23 of them are input output pins. 23 input output pins. 2 pins are used for power supply, that's VCC and ground. And the remaining 3 pins, they are actually used for ADC operations. Since Atmega 328 has an inbuilt ADC, we need to power up that ADC, so 2 of these pins are used for powering up the ADC that's present inside Atmega 328. We call them AVCC and ground again. And there is one more pin that's used with respect to ADCs, that is known as analog to digital converter reference, A reference. We'll be discussing these pins in more detail when we will discuss the analog digital converters of AVR microcontrollers. Of the 23 pins, of the 23 input output pins, 23 IO pins, they have been divided into 3 ports. We have named them as port B, port C, and port D. Port B has 8 pins. It's an 8-bit wide port. Port C has got only 7 pins, and port D has also 8 pins. In other AVR microcontrollers, we might have port A, port E, port F, maybe up to port L. Some of the AVR microcontrollers have ports A to L. But in case of Atmega 328, we have only 23 input output pins, and they are divided into 3 ports. Port B has 8, port C has 7 pins, and port D has 8 pins. So let me try to draw a pin diagram of Atmega 328 microcontroller. Okay, that's fine. I can call this pin number. This may be pin number 1, this may be pin number 7 and 8. So this may be pin number 4, pin 2, 3, 5, 6, 9, 10, 11, 12. Okay, 10, 11, 12, 13 and 14. Similarly, on the other side we have 14 more pins from 15 up to 28, and these pins may be 21 and 22, 25, 26, 27, 24, 18, 19, 20, 16, 17. So out of these 28 pins, we have 2 pins for power supply. They are pin number 7 and 8. Pin number 7 and 8, VCC and ground. And then we have a few more pins for analog to digital converters. They are pin number 20, 21 and 22. This analog to digital converter VCC, and then analog to digital converter ground, and we also have a reference. The rest of the 23 pins are input output pins, meaning from those pins we can take input inside the microcontroller from a sensor or from any environmental variable, and we can also send output to the data to be maybe displayed on a screen, or to do some job like to run a motor or turn on something, maybe glow an LED. So, and these 23 pins are divided into 3 ports: port B, port C and port D. We have our port B from here, from pin number 14, we call it PB0, the 0th pin of, or the first pin of port B. PB1, PB2, PB3, PB4, PB5. Then the rest of the 2 pins are here at pin number 9 and 10, PB6 and PB7. You don't need to remember the pin diagram exactly, but you must know that there are ports, there are pins for voltage supply, and there are pins for ADCs. And then we have PC0. I have missed 22 here. So this will be 22 ground and 23 port C. Port C will be from 23, PC0. It has only got 7 pins, so PC0 to PC6, PC1, PC2, PC3, PC4, PC5, and then we have PC6 here. So these are the 7 pins of port C. Now we have port D. port D starts from pin number 2, PD0, PD1, PD2, PD3, PD4, and the rest of the pins are here, PD5, PD6 and PD7. So this is our Atmega 328 microcontroller. Atmega 328 microcontroller with 28 pin IC, dual inline package, 28 pin IC. This is the pin diagram of the various ports and various pins. So next we'll be discussing about what exactly is the function of these input output ports and how can we use these input output ports in our embedded systems. What are these input output ports? They are actually terminals where from we can take input or give output. And you should remember that this input or output will be electrical in nature. These will be electrical signals. We can put a particular voltage on some pin and we call that giving an output. And that voltage, since it's a digital IC, can only be 0 volt or 5 volts. That means it can either be what we call as low or high. So using some instructions to put either 0 volts or 5 volts to any of these pins is known as outputting data. That is how we output data from a digital IC. We either put 0 volts or 5 volts on these pins. Similar is the case by taking input. But since there's an inbuilt ADC and that inbuilt ADC is connected to some of these input output ports, so some of these ports may also understand anything between 0 to 5 volts, that any analog voltage between 0 and 5 volts. But in general, microcontrollers understand only 2 voltages, 0 volts and 5 volts. And where are those input output port, where are those ADC, where is the ADC connected? You must remember that some of these input output pins, in fact all of these input output pins, have more than one function, have dual functions, and in some cases they have more than 2 functions. For example, this PC6, this is also used as reset pin. That means we can reset our microcontroller when it's working. We can reset it to start from the 0, to start from the first instruction, start executing from the first instruction. We can reset it by giving a high voltage here at PC6. So PC6 is also used for input output or output, or it can be also used for resetting the microcontroller. Similarly, sometimes we need to connect to the external oscillator for the microcontroller. We can connect the external oscillator here at pin number 9 and 10. XTL1. So pin numbers 9 and 10 also have dual function. They can be used as the parts of port B for taking input or giving output, or may also be used to connect the external oscillator. Similarly, port C, the internal ADC, the inbuilt ADC inside the Atmega 328 is connected to the pins of port C. So port C can also be used for the normal input or output, or it can be used to take the analog data from the outside world and convert that into the digital form before it is processed by the microcontroller. So we have the ADC here, ADC 0, different pins of ADCs. We can connect more than one analog device, ADC. And similarly up to ADC 5. Now, how do we take data? How to use any of these 3 ports as input output? Before using any of these 3 input output ports, they must be configured either as input or as output. After that, we can either take the input from these ports or give output on these ports. You must remember that each port of AVR microcontrollers are here at Mega 328 is associated with three registers. In the previous discussions, we discussed that apart from the general purpose register, our microcontroller at Mega 328 also has some input-output registers, or what we call special function registers. Some of those special function registers are associated with ports. We may be discussing a lot of special function register as the course goes on. With each topic, each functionality of the Atmega 328, there are some associated input output or special function registers. So with these ports, each port has three associated registers. One of those registers is used to configure the port as output or as input. The second register is used to give the data as output. If we need to output any data, we need to put that data into that particular register associated with that particular port. Similarly, the third register is used to take the data. Whenever data comes from external world to the microcontroller on a particular port, that actually gets stored in a particular register associated with that port. And from there, we take it into the processor for processing. The name of these ports is, we have got, let me change the pencil, or it's fine. We have got port X. We also have got data direction register X. We also have got pin X. This X may be the ports, port B, port C, or port D. For example, in case of port B, the three registers will be, we will be having port B, DDRB, pin B. And similarly, in case of port B, C or D, we will have port C, DDRC, pin C. And in case of port D, we have port D, DDRB, and pin B. DDRB or DDRX is used for configuring the port as input or output. We need to configure it. How do we configure a port as input or as output? We'll see that in a moment. So we need to configure the port before writing anything to the port, or before getting the data from it. We need to configure it either as input or as output. After the configuring the port input or output, if we have configured it as an output port, before, how do we now send the data to the outside world? By writing that data to the port X register. This is used for output. And if we configure the port as input, how do we get the data from the input? That will be actually stored in this pin X register. So this is used for input. So these are the three registers. The internal assembly of all these ports, in fact we will be discussing the internal assembly of a single pin, and that may apply to the whole port and all the three ports, is something like this. For example, this is my outside world, and this is the internal of inside AVR, inside Atmega 328. This is the microcontroller part. Fine. So let me discuss a single pin. A pin externally, I am only seeing a single pin, like the pins of the IC we see. It's a single pin. So maybe it is the pin and nth pin of any port of these three ports of port X. For example, it may be pin 0 or port B. So how it is internally connected with these three registers, port B, DDRB, pin B. In this case, since I have taken only one pin, I will be taking only one bit from port B, one bit from DDRB, one bit from pin B. That is the associated bit of the port B. Okay, one more thing. All three registers are 8-bit wide. That means port B is 8 bits wide, DDRB is 8 bits wide, and pin B is also 8 bits wide. So for each pin 0, there's an associated bit, maybe bit 0 of port B. For pin 1, there will be associated bit, that's pin 1 of port B. Similarly, for DDRB, there are 8 bits. Each bit is associated with one pin of port B. So for pin 0, we will have bit 0 of DDRB and similarly bit 0 of pin B. How are these connected with these bits and in general with the ports? We have a buffer here. Using this buffer, so I have told you that anything we need to put in the outside world, we need to output the data, we put that in port B. So port B, we need to put that in the port register. So port X, this corresponding pin of port X is connected with the inside world using this buffer. So whatever we put in port X will be sent to the outside world. But at the same time, this outputting or inputting will be controlled by the data direction register. So the data direction bit will be like this. ddrx.n. So if we put a 0 in the data direction register, this buffer won't work. There will be high impedance between this point and this point. So in that case, we can't use the pin as the output pin. So that means any data we put in port X will not be sent to the pin, to the outside world, because there is a high impedance path between these 2 points. But if we write 1 to our data direction bit, there will be a low impedance path, and anything we write to the port X will be sent to the outside world. This is how we configure a port, by writing something to the data direction register. We may write 0 and this port won't work as output port, and if we write 1 to our data direction register, since this data direction register controls the buffer between the port X register and the outside pin, it can be used. After that, this port can be used as output port. Similarly, the incoming data, as I have told you, gets stored in the pin register, and in case of pin N of port X, maybe pin X dot N. I hope that's clear. We will be discussing some of the instructions that may be used during input output transactions of Atmega 328 microcontroller. I think that we will discuss in next class. Let's call it a day for now. Thank you.